All right, are we starting? Hi, good evening, everybody. Sorry, I need to speak slower. I've also got a funny accent, so if you need me to repeat anything, just let me know. So I'll be talking about architecting on Ethereum. I think that there are a lot of considerations that tend to generally go into building applications. Most of those considerations are not necessarily just one thing or the other, but they tend to be things about stuff like a specific need that you might have if you want to build a DeFi application versus what the user expectations are of that application versus what, in some instances, other external factors are. So your architecture tends to have to take into account all of these things, and then you come up with something that tends to find a middle ground that solves or at least covers most of the needs of all the participants, but most importantly, of course, of the business, right? And that's what I'm going to be talking about, business. I should probably have said architecting on Ethereum for business. So I'm Stephan February. You can find details of my profile at February SG. I would suggest that you do not pay close attention to the profile that was shared on the Ethereum Meetup group. In that profile, it looks like I've actually founded 3 or 4 different blockchain-related companies. I think that that is incorrect. I suspect that there was a mix-up with ChatGPT and a zealous marketing intern. So, but yeah, so topics for tonight that I'm going to be covering are token considerations. Like if you're going to build something with the blockchain or with Ethereum in particular, some sort of a token is going to be involved somewhere, and you're going to need to think about the token and what the token is meant to do and how you're going to be using it. I'm going to be discussing some general architecture or general architectural considerations, and then specifically I'm going to talk about one specific aspect of application delivery, which is the platform model, which typically is where you have two-sided marketplaces, and then you have a platform in the middle which sort of brings people together. How you should think about building these applications, but specifically, how do we scale them with what we have today on Ethereum? Yeah? All right, so the first item, right, which are token considerations. So tokens, I like to think of them as having features and that there are business constraints that surround the whatever it is that we want to do, right? So first of all, when we think of features, does it have to be fungible, or can it be non-fungible, or does it have to be one or the other? This obviously is the first question, right? And when I say non-fungible token here, I literally don't mean the sort of narrow definition that has made NFTs popular. I'm talking about the idea that one token is either completely interchangeable with the next one, that fungibility, versus whether or not they are completely distinct entities. So think a bus token or a redeemable voucher. Don't think money like Singapore dollars. Yeah. And then, can I split the locked value of the token? So typically a token has something attached to it, and that can be something of value, whether it's a value is represented as an Ethereum or as a number attached to a different token. I'm allowed to split that value because it might be counterintuitive, but you can actually have a fungible token that you can't split the value of. And there might be uses for that, right? So it's not necessarily the case that you have a fungible token that you don't, that you have to have this ability to split and merge the token. And the reason I mention that is because it might allow you to think about interesting things and interesting use cases that you might be able to cover with that sort of thing. Does there have to be data attached to the token? And if you're going to attach data, where is the data going to live? Do you want the data to live on chain, or can the data be stored off chain? Do you need some way of giving an attestation of the data that's off chain inside the token or inside the contract that lives on chain, right? So think an off-chain data structure like a Merkleized tree or a Merkle tree, where the root of the Merkle tree is a commitment inside the token or inside the contract rather. Is it transferable peer-to-peer? This is also very important. And the reason I mention this is because it sort of ties into some of the constraints that the issuers have on the right-hand side here. Peer-to-peer transferable, I mean, I can send my Ethereum to somebody else. This new token that I want to come up with that's going to be used in my business, can I send it? Probably can, because it's the blockchain, it's permissionless, it's trustless, but am I allowed to, right? Quite often you're not allowed to. Can I send a stablecoin, a Singapore stablecoin, peer-to-peer, without a digital payment license? Probably not. Even PayPal is not allowed to do that, right? Person-to-person payments in Singapore, it's not allowed. Is it revocable by the issuer? And now we're talking about permissioned tokens, right? Not everything is permissionless. In business, it is the case that if somebody gives you a voucher for a stay at a hotel, they have all sorts of limitations on that voucher. You can redeem the voucher between this and that date. The voucher is non-transferable. Your name is written on the voucher. Your passport is written on there as well, so you can't transfer it. So if I want to make a digital representation of this voucher for a business, like a hospitality business, then I probably need to think about encoding these same constraints that the business requires into the voucher. And having the ability to revoke the voucher, in other words, rug you from your voucher, yeah. Maybe there is rugonomics built directly into your token. So, issuer constraints. I mentioned regulatory restrictions before. For example, imToken, right? We're operating as a payments company inside, well, not imToken specifically, but the part of imToken that I work for, which is the RIVO network, is actually a regulated payments institution. And we definitely are regulated by the Monetary Authority of Singapore. So we have to think carefully about the things that we do on the blockchain and the things that we are allowed to do. So when you build an application, it's important that you know the landscape, right? There's a lot of stuff that we can do without the permission that is actually not covered by law. But if you want to stay out of jail, I suggest that you know where the lines are and where the boundaries are. And it's okay to push the boundaries now and again, but you step over the line, especially in a place like Singapore, they're gonna come down hard on you, right? Anybody who's lived in Singapore for a while knows just exactly what I'm talking about. So, custody, right? If I'm the issuer, I'm issuing this token, what do we do about custody? Am I giving you complete non-custodial? Is the relationship completely non-custodial? In other words, when I give you the token, you have the token. If the token shows up in your wallet, your keys govern what happens to the token. Versus, I give you the token, but the token can only be moved if I agree in the way in which you want to move it. You guys might have recently heard about the Monetary Authority of Singapore publishing a paper called Purpose-Bound Money. So that paper on purpose-bound money is very interesting. So anybody who's interested in these sorts of things, I suggest that you go and read that. It gives very clear guidelines on the types of both financial instruments that are regulated and non-regulated financial instruments, and also sort of gives a framework on how we can think about the idea of wrapping value and then moving that value around. Now, certain types of wrapped value, you're definitely going to have a different custodial relationship than completely permissionless, non-custodial wallets, right? So it's good to think about stuff like that. Security is always a consideration, and there's always a lot of things that we can say about security, right? But definitely something to think about in the context of trying to figure out what we're doing with the tokens that we're building. We want to know, for example, how do we move or transact with these tokens? The digital keys or the private keys and that are used to authorize the movement of these tokens, where are they kept? If we are doing a fully custodial arrangement. In other words, where the business entity maintains custody of the keys allowed to move tokens through the blockchain, then the security of those tokens become very important. Then it becomes important to think about things like hardware security modules, where you basically have the same type of security that you have, actually better maybe even, than what you would have with a hardware wallet. So think enterprise hardware wallet, right? Instead of a small little token that you have, like the imToken wallet, the IM key right back there, instead of a one that you hold in your hand, think a 1U or a 4U rack server that's dedicated to performing massive numbers of computations in a secure manner where your private keys can't be extracted. So just a much larger version of something like the hardware wallets that we get for that you can get for personal use, like with the IM key. Performance and user experience. Performance and user experience are extremely important because from the user's point of view, they need to know whether or not the application is actually working, right? If you're just sitting, if you just sit there with an infinite spinning animation, then the user doesn't know, am I waiting for a confirmation from the blockchain? Am I waiting for something from the application? So even if your interaction can't, let's say for example, I'm moving a token through the network, even if the confirmation for the token does not happen immediately, and if I know ahead of time as the developer that the confirmation is not going to happen anytime soon, it's better to let the user know, hang on, we've sent it out to the network, and we've all seen this before, right, with our interactions. The tokens basically go out of our wallet, it leaves, but then, it doesn't show up in the place where it is meant to be, but we know, because we've been told by the user interface that it's in the network somewhere, it will pop its head out at some point, and you know to expect that. So setting those expectations for the user are important, but not just setting it for the user, also when you figure out what it is within this larger context of the application that you're building, you can actually structure the entire architecture of your application in such a way that you can give great user experience, especially when you talk about scaling, right? Where you give great user experience and you combine it with great security on layer one. Because that's kind of the gold standard, right? Right now, you end up with a situation where we are trying to figure out the scaling solutions for layer two, and quite often you might come up against a scenario where it's not quite clear what am I supposed to do to give good user experience while maintaining both the layer one security while transacting on layer two, but also not making the user wait for too long. So how am I doing for time? Okay. So this is the sort of simplest architecture that you can think of, right? You have a number of users of this business who has a backend server, and that backend server connects directly to the Ethereum network, which means that in practical terms, there will probably be two servers running in a data center or in the cloud, one running your application either on a virtual machine or in a Kubernetes cluster, and another instance running an instance of the Ethereum full node, right? So you have a full node running right next to your application in a data center. And these two communicate, and one of them is on the peer-to-peer network for the Ethereum nodes that they communicate on, and the other side of which is your application, that part faces the user and the user interacts with that part. So the user does not actually directly interact with the blockchain themselves through this kind of model, although they can go to a block explorer if you're exposing some part of the application. Technically, for a boomer like me, we don't like something called leaky abstractions. So if your application exposes part of the blockchain and your application, the thing that the user is interested in has nothing to do with the blockchain, the user shouldn't see it. So that is called a leaky abstraction. So for example, let's say that I've got a ticketing application and the user wants to book a ticket. The user, from the user's point of view, they want to book a ticket, make sure that the ticket is going to be redeemable at the point of redemption at the venue. They don't care about the block explorer or the transaction ID. They don't want to go and check that I'm not plugging them or anything like that. That is not the case for all applications. If I'm basically trading on a DeFi network, then I want to make sure that things are actually on the up and up, and I want to maybe go and look at the block explorer to see the tokens are showing up in the place that they are. But for some applications in businesses, think about whether or not you want to leak the blockchain abstraction to the user, or whether or not the user should actually see abstraction be exposed. It might just create confusion, right? So it's something for product folks to also think about. I'm sort of going to progressively get decorate with more, add more bits into the typical architecture, and then work towards sort of the standard high level of what most modern applications on Ethereum would look like. So this one I call the API provider, where you basically have the users interacting with our business through the backend server. Our backend server, we've now realized that, you know what, we're in the business of selling widgets, we're not in the business of running Ethereum nodes. Maybe I shouldn't have to pay for Stephan to sit around looking after the Ethereum node anymore. I don't need a blockchain guy in the company. Sorry, Stephan, maybe go find something useful to do with your life, okay? So Stephan's out of a job, but Stephan is now free to the gainful employment. Infura, maybe Stephan can go and work for Infura, which is an API provider that runs a lot of blockchain nodes, or Ethereum nodes specifically, in their backend, and then provide a beautiful API for the still employed developers within backend server company to connect to, right? And those then go through to Ethereum. So instead of the backend server company now running an Ethereum node directly, they basically have all of the stuff. I'm going to step over carefully. All of the stuff over here is now outsourced, or is purchased as a service from a third party. This is incorrectly labeled processing steps. No, it's correctly labeled processing steps, sorry. Okay, so the reason that I've actually put little yellow tags on the various parts here is because the next slide I actually want to make a point about the various parts of the processing of your interaction between the token, within the context of tokens. If there is some sort of thing that needs to happen where the user either explicitly or implicitly has to interact with a contract that exists on the blockchain, that processing of that interaction that you are brokering for the user goes from step 1, 2, 3, 4. But I don't like drawing it like this. I want to draw it in a different way because I want to make a different point about something else. So I'm tagging it here as step 1, 2, 3, and 4. And then on the next slide, I've drawn it like this, which is 1, 2, 3, 4. 4 is layer 1 Ethereum. 3 is the API service provider we had previously, and then 2 backend, and 1 is where the clients are at. And then if you go down, then you see that I call A straight-through processing. Straight-through processing, is a boomer term, something that I know about because, in the 80s it was all the rage, that instead of having to call up somebody on the phone to do something with a server or a system, we do straight-through processing. You click a button on the web and it hits the mainframe like that. Amazing. There's no more papers being shuffled. So within our context, straight-through processing here just means that the action that the user is trying to take, that you would like to have reflected on layer 1, that it sort of persists all the way through the layers that you have brokered it through to layer 1. More or less unchanged, mostly just sort of handed off and gone all the way through. I'm going to contrast that with a separate one below. I maybe want to say what sort of things A refer to. A would refer typically to something where, remember before I was saying about leaky abstractions. So typically where the user actually cares about what's happening on the blockchain and you need to expose that abstraction of the blockchain to them in some way, then you would want to provide the straight-through processing the straight-through brokering, where let's say the user wants to move a token from their wallet to another user's wallet, and they want to observe that on the blockchain, then you provide the straight-through processing, and then the user can see that the tokens have actually moved, right? My NFT is now showing up. The NFT has moved from my wallet to a third-party wallet, and it's actually shown up over there. The user needs to see that, so that's straight-through. That is very different from a business wherein you don't need to leak the blockchain abstraction. Very specifically, I mentioned before vouchers, right? But there is a general class of applications or problems like this. Payments is one of them, where the relationship between the person or the person making the payment and the merchant who receives the payment is actually brokered by a third party. And then you have a domain-specific part, which is the payment processing, which deals with accepting money from the customer, and then the money doesn't have to immediately show up in the merchant's account. The token that, even if it's a token that you take from the customer is not going to go look in the blockchain to verify that the money has showed up in their account. The merchant is not going to look into the blockchain to go and see whether or not the token has basically moved from the customer to their wallet. Why? Because there is a third party brokering the interaction between them. There's a payment processor, and the reason why there's a payment processor is because this sort of activity is actually regulated. There has to be a trusted third party in the middle. Quite often in a lot of things that we do generally with the blockchain, we have disintermediated that trust. But there do still exist in the world today use cases where the blockchain, where we can start sort of that middle ground where we are transitioning all parts of the economy to the blockchain, that you still need to have a trusted intermediary, whether it is because of regulatory force or because of just the customers needing still to have this feeling of a trusted relationship. You'd be surprised, but in a lot of businesses, they do not want trustless interactions. They want trusted parties to interact with. And for those especially, the trust exists between the merchant on the one side. And when I talk about the platforms, I'll talk about it again. The trust exists between the merchant and the transaction in the payment processor. And then there are other parties in there as well. The trust exists between the token holder or the person who wants to make a payment and whoever issued them that token, right? And then there's a whole interaction of brokering that happens in between them. And we're doing amazing things with blockchain to compress and disintermediate a whole bunch of the previously known third parties in that mix, so that it becomes a lot more simple, comes a lot closer to straight-through processing. But it can't be straight through yet because the governments don't like it. Eventually we'll get there, I'm sure of it. And the way we'll get there is probably through something like what that paper explained with purpose-bound money that MAS published. So we'll get there eventually. It will be the case eventually, I think, that we'll be able to make a direct payment to a merchant with a token that with a non-custodial token that we hold in our wallets, and the government won't care because the infrastructure would all basically be set up and all the contracts will be on-chain and governed, and the right people will make money, right? So the thing that I forgot to say at the start was you guys should feel free to interrupt me and ask questions at any point in time. Don't save your questions for the end, because we might actually run out of time. So if you have any questions about this, feel free to ask now. If not, and if it's clear, oh, sorry, so the one part which I didn't mention, which was in B, that domain-specific part that I mentioned sort of on the left-hand side there, are interactions where the business just has to interact with the user. They'll take care of maybe persisting stuff in a delayed settlement to the blockchain in the back end, and that stuff doesn't have to show up on the blockchain immediately either. This has implications for L2 scaling, for example, right? Where you do a roll-up or where you do some sort of layer 2 scaling implementation that does not need to persist to the blockchain immediately. It has to show up eventually, like way eventually sometimes. But as long as the user experience and a trusted relationship between you and the business still exists, then you're okay. So we're getting close to the end now. So I call this slide the L2 platform slide. Think of it as a platform business interacting with a layer 2 scaling solution. And here, so I've got a third slide, and I was thinking about it, and I realized that I should probably have been clear that the solution here is not general layer 2, it's actually specifically layer 2 rollups. So think Starknet, sorry, does everybody know about the different sort of layer 2 scaling solutions? The rollups versus the, everybody familiar? Yeah, okay. No? Okay, so there are essentially two different types of ways of making the, think about it this way. If you have a storage area where you have a limited ability or a limited throughput where you can actually write to that storage area. And this used to be the case in the old days when you had reel-to-reel tape mechanisms for storing data, right? There is limited throughput for saving stuff. It has massive capacity, but the bandwidth is restricted, so you can't write very efficiently to it. So what typically had to happen is you had to buffer a lot of the stuff and then wait until everybody went home, and then tonight you run your reel-to-reel and you do all that processing when nobody is actually on that. So roll-ups and particularly there are two separate camps in the roll-ups, which are optimistic roll-ups and zero-knowledge roll-ups, which we won't go into, but consider roll-ups as sort of aggregating a bunch of transactions, compressing them into something small, which is a zero-knowledge proof in the case of ZK roll-ups, and then that will fit the bandwidth and then will sort of occasionally be posted onto layer 1, and you still actually, it ends up showing there eventually. And the reason why this is interesting is because all of the interactions, the peer-to-peer interactions between you, me, and you and your friends and everybody, all of us, can now happen away from layer 1, where layer 1 fees right now is about $4 on average, thereabouts, US dollars, which is, I don't want everything to happen on layer 1, right? Sort of casual interactions, I don't want to happen on layer 1. I can have it happen for a much smaller fee on off-chain, and that in all places where it happens off-chain with the promise that it will eventually have some sort of a proof of existence on the base chain on layer 1, all of those off-chain interactions are called layer 2 solutions, because they prevent or they alleviate congestion on the base blockchain, essentially, right? So in this diagram, so this is a really high-level diagram, right? So typically, this is the diagram that an architect will show to the business folks. This is not the diagram that the architect will show to the developers. Well, they probably will see this, but there are lots of levels of detail that need to get broken up, and more, where you actually have to expand and go further into detail about exactly how these things actually talk to each other. But at the really, really high level, these components typically exist in all applications, right? Especially when you're interacting, or specifically in the context of building applications for Ethereum. That is that you'll have a roll-up service provider, and the reason for you having a roll-up service provider is similar to why there was the API service provider before. You could probably in your business do the zero-knowledge roll-ups yourself if you had enough data. But for most people, you know, maybe just buy the competence from somebody else who can actually do it for you. And there are a few companies who are actually competing right now with different types of solutions that will actually do this aggregation of everybody's transactions and put them through. So your application will, so again, this is a platform, right? The platform on the right-hand side has some sort of customer, and on the left-hand side it's customer. If it is a booking agent for For hotels, right? If I'm a travel agent, then I have an inventory of hotels, rooms, and Airbnbs, and all the merchants who actually provide those things. And my application, I expose a fancy web application where I give NFTs to people to entice them to come and book hotel rooms through me. And now I've got to basically coordinate the fact that when somebody shows up at the Airbnb with this NFT, that the host will actually let them in, or maybe the host has one of the newfangled smart doors where I can just actually go with the NFT. The NFT knows it's booked within this particular time slot that has been programmed into the IoT device. I can go up to the door and it'll open for me automatically, and there'll be a little candy waiting for me on my pillow, right? The candy has got nothing to do with the blockchain. All of this, of course, has to happen within the context of something that has to happen on the blockchain. But again, we're doing it now through a layer 2 service provider, or I should say a layer 2 roll-up provider, because I also want to talk about something which by now people are probably thinking of again as boomer tech, right? Nobody talks about state channels anymore, but I kind of like state channels. State channels, does anybody know what state channels are or where they come from? You know what state channels are? Does anybody else? No. Okay, so some of the folks still remember that state channels were actually meant to be a thing. So state channels kind of got supplanted by tech in the roll-up space. If you guys remember that there was supposed to be sort of 64 side chains in the Plasma network that was supposed to provide scaling. These were supposed to happen on inside state channels, and it hasn't gone completely away, but the energy and the excitement these days are within the roll-up space. The reason I mention state channels is because I don't think state channels are dead, and I don't think they should be completely discarded out of hand. I think state channels still has a place. I think that probably for general use going forward, maybe even for larger businesses or larger applications, you probably want to do roll-ups through a third-party provider. But I think that there are lots of smaller use cases where it might actually even be preferable because it might be less expensive and your interactions you'd broker directly with the blockchain rather than through a third party. Is some of the benefits, right? So, okay, that's why I drew the lines. I drew the lines, and maybe this is one of the points I wanted to make about this. Over here, with my L2 integration services, okay, I should say which is which parts of my application and which are outside. The orange bits are not my application. The orange bits are things that I purchase from a third party. Everything up there, all of them are actually stuff that I've built myself. Not literally, but that's something that if you're building a business, then you would want to build the bits above, and then same here. But pay attention to the orange lines that I've drawn in here, because I want to make a point about those. The orange lines here with state channels, because of the way that state channels work, you actually as not just the business, but also as the participants on the customer side, not the customer side, but let's say the customers on the left and the customers on the right. All of these participants actually have the capability of directly interacting with the blockchain as well, as part of this entire ecosystem or as part of the greater solution that the state channel provides. And they don't have to do it consistently, constantly, or all the time, but I do like the security that you can then move to potentially non-custodial relationships or other sort of interesting aggregate relationships of where you have maybe aggregate state channel hubs that with security, and doesn't have to be a third party that you pay. It could just be you and a couple of your mates who basically commit money to open up a channel to a particular state channel as a contract, and you all interact through that one, and you have some way, a trusted relationship between you and your mates where you're all committing to that. I don't know, but the possibilities are endless, right? and the API service provider that I put at the bottom here, the reason you don't see layer 1 is because this is kind of implicit, right? When I send a transaction through Infura, Infura can't do anything with my transaction except send it on to the layer 1 node and maybe charge me a fee for the privilege of sending it through them. As opposed to this here, where you kind of have to trust that the layer 2 rollup guy is going to do the job, and then they're going to charge you a fee for the job that they've done, and then eventually your rollup will show up on the blockchain. I've been quoted 24 hours, maybe, preferably between 24 to 48 hours. You'll see it, and if it doesn't, then to see whether or not it has or not. We're not going to send you a response, right? So I like state channels, but these are very sexy because the math is sexy, right? But I like state channels. They're a bit boomer, but they kind of work for specific use cases. Yeah, any questions? That's pretty much about what I wanted to say about that. Any questions?
Could you go back to the AB?
Sure.
Yeah. So for layer, if let's say you want your layer 1 actually stop. Oh, okay.
Yeah. So we have YouTube live.
Yeah.
Ooh, what happened? Let me try again. I think it's
Go for it. That's okay, you can go.
Oh my god.
I don't know if it's you or me.
Okay, let's try it.
One more time?
Okay. Okay. So my question is regarding the layer 2, but in this setting, if let's say you want to keep updating information from layer 1 to the backend, you kind of should use a layer 2, right? What should the architecture be?
In B, scenario B?
It's kind of scenario C, right? Because there's no layer 2 here in this. Take it that the backend is equivalent to layer 2, then what should B be?
Oh, sorry, maybe I didn't make that clear. So I was being a little bit abstract when I was talking about the solution in B. Either of these two can actually be using well, actually layer 1 is definitely all the way through to layer 1.
Yeah,
And then B is the delayed settlement. It was kind of implied on my part, and I didn't draw it in clearly enough. I'll update the slide. But the implication there is that within that delayed settlement time, and I mentioned the 24 to 48 hours, right? You can pretty much do whatever you're doing, whatever you need to. You can stick a layer 2 solution in there, or anything else.
Yeah, let's say it's a smart contract, and a few months later you want to update stuff.
Right.
You shouldn't use a layer 1 to update it, right? You should use layer 2 and then push into layer 1. So how is that architecture done?
Okay, so it is pretty much still the same. It would be either this or this. Typically what has to happen in your case, in the case that you mentioned, which is actually a really good example as well, because what happens in the intervening time, let's say you want to keep 1 month's worth of state transitions or state updates. All of that has to basically be done here. You have to store it in your database. You have to make sure that you record each of the state transitions depending on what sort of commitment you're going to make to layer 1 eventually. And in the case of a really long delay, I don't know if you can delay something like Starknet. No, because Starknet decides when they roll up their commitments, and so does Optimism. You don't get to decide. When you send your transaction, it goes through. The only time where you actually have the control on whether or not the commitment is made to the blockchain is with the state channel. And if you are in control of the state channel and all the parties who are participating in it agree. So if you have that long of a time for you to collect state transitions, then I think that state channels probably are the way to go with it if they fit your use case. But generally, I don't know that you could always buffer your transactions off chain, but that is risky with Starknet or with the other layer 2 solutions, because buffering off chain means that you run the risk of the state on layer 1 if you're not careful, you won't accurately reflect what the eventual state on layer 1 actually needs to be. Because the sequence of the contracts that need to be committed might be non-deterministic when you broadcast them, and if they're not in sequence, then some of them might not persist. It's a bit risky. Yep. Any other questions? Sure.
Are there tools or templates or examples for the state channels on Ethereum?
Yeah, there are a couple of companies. There is one called Nitro, Go Nitro. They have a pretty good one. There was another one that I found that. So I should say, right, that I haven't myself. I have to find my browser now. I haven't found. Let me see. Okay. Sorry, I'm going to move this off because I might accidentally open up nuclear codes. So, which you're not allowed to see. So let me see quickly.
You don't mind private keys?
You know my private keys? I'm trying to remember now the one that I found. Perun. I'm terrible with remembering names. So there is Perun, who still seems like they're alive, and then there is the Go Nitro implementation, which had a GitHub commitment just 3 days ago, because that's normally how I tell whether or not a project is dead or alive. And then Perun network. For some reason, I can't find a good link. But Perun, they still look like they're pretty much alive. Go Nitro was from a company, I think they're called, I can't remember their name now. Or rather, Go Nitro is basically the Go implementation of the network. But my research basically sort of suggests that Perun and one or two others are the ones to look at right now. But there are a few. There are a few out there. Any other questions? Yep. And then over there. So we have 2 questions. Sorry, the mic is back there. We'll come back to you.
Maybe I'm lazy. So I'm just asking. This morning I read in the newspaper there's vulnerability in the wallet. They say depend on the software developer whether they already patch it or not. So is it? You know any details about the vulnerability?
A vulnerability in which wallet? Sorry.
Most of the wallet, they say.
Oh, most of the wallets. There was, I don't know if it is, so I didn't read the article that you're referring to today morning. I do know that last week there was a little bit of a scare around a very specific multi-party computation involving Palea curves, which is basically sort of groups of people doing multi-signatures for particular types of wallets. And then also there was a bit of research that came out around a vulnerability that exists within elliptic curve DSA that specifically, under a very specific circumstance, if you have two signatures over the same hash, and one of those signatures is a faulty signature, that it becomes possible to reveal the private key with just the public key, the message, and the signatures. But those are but both of those vulnerabilities are a bit esoteric and not the sort of thing that most people need to worry about. I don't know if anybody else knows anything about the news that dropped today morning that you're referring to. I don't know, did you read them in the newspaper or online? In the Straits Times this morning, then it was probably last week's news. It's probably referring to these vulnerabilities that were found in these wallets, or rather within this very specific area of cryptographic signatures, which tend to be used by people like BitGo, or the custodial services tend to have multi-signature wallets that they protect with. And a lot of them actually use this particular way of doing the ECDSA. I think it's Palea signatures. And there is.
I know which one is that. I think it's the one that disclosed by Fireblocks this morning. The Bitforge vulnerability.
Did Fireblocks do another one? Because last week's one was by Fireblocks. Is it the same one?
2 days ago.
For 2 days. Sorry, time works weirdly in my head. But yeah, sure, maybe on the weekend. Yeah.
Okay, thank you for the thoughts. You mentioned about the DApp architecture on layer 1 and layer 2, but we have some gaming partners who are actually working on the multi-chain architecture. So how do you think about the differences between using layer 2 for scalability or and using different chains for not only about scalability, but also about targeting different communities or different users. So
yeah.
How the architecture on multi-chains look like?
I think that's actually a fascinating question, and a lot of people have proposed this, right? Which is, as opposed to doing a side chain, maybe just use a fast blockchain to support the scaling of a slow blockchain, right? That's kind of what folks are saying. There are two interesting things that is notable and noteworthy here. The one is the economics, right? So it starts to become about economics and about who absorbs economic value from whom in this scenario. Let's put aside the economic considerations for the time and just say that we actually want to do this sort of scaling. I think it's a brilliant idea. However, the sorts of things that need to happen are we need to have the capabilities on both chains that you would like to integrate to do certain cryptographic operations, or at least certain types of operations that allow for cross-chain swaps, for example. So HTLCs, hash time locked contracts. If you guys don't know, maybe ask me afterwards. I can explain what a hash time locked contract is. But there are things like HTLCs which allow you to essentially do atomic swaps cross-chain, but both chains need to have support for the notion of there need to be certain primitives supported on the chain so that they can participate in what is essentially a multi-party computation through the HTLC, because you need to do stuff like both parties need to lock funds on each of their chains, and then they need to, and those funds need to be locked with a time delay. If you can't do a time delayed lock on your chain, then you're kind of out of luck. Bitcoin BTC has a particularly nasty feature which makes it difficult, which is what I like to call a rug by fee. They call it a replace by fee, but it means that you can rug the transaction after you've broadcasted by posting a new transaction with a higher fee attached to it, right? So if you're participating in the RBF, not in RBF, sorry, if you're participating in a HTLC with BTC, for example, with somebody on BTC, then you would want to be careful that you don't get rugged. And while the HTLC exchange kind of has it built into the exchange, the atomic swap, that you can't, or the cross-chain atomic swap, I should say. That reminds me, you basically want to be careful with that. I do want to mention this company that I worked with these guys in a previously. I'm not seeing anything showing up over there. But these guys have done great work in building out infrastructure. Is it CoBlocks or CoBlocks? Roblox, really? Come on. Of course, I'm not going to find them now. I can find everything, including a paper on the ACM. But there is a company, CoBlocks, that I worked with the developers like maybe in 2019, and they have since done some really good work with actually doing cross-chain atomic swaps, which is a key component of cross-chain scalability. If you want to leverage another scale-to-scale one, then you need to figure out a way to do atomic swaps of tokens across them in some way. Yeah. In that case, maybe, I don't know, you need to figure out a way, from an architectural standpoint, because maybe I didn't answer your question right. From an architectural standpoint, your infrastructure will probably end up becoming interesting, to say the least, because you now need infrastructure that you probably can't really outsource anymore for your end of the atomic swap, because you really want to. Because consider it this way, right? If I'm trying to perform an if I'm trying to do a HTLC with somebody on another chain, let me bring this in again. If I'm trying to do a HTLC with somebody on some other chain, and I have to traverse through a roll-up provider onto the network, I don't think that's going to work. We are probably going to have to go back to this diagram here, right? Where you're probably going to have to do something directly on the Ethereum network, or perhaps this way, where you have a smart contract on Ethereum, which both parties transact through as the Ethereum side of the HTLC, and then on the other chain, if it's UTXO chain, for example, because these tend to be the interesting things, right? How do you go from a BTC to an Ethereum cross-chain atomic swap? Because one is UTXO and the one is account-based. Which CoBlocks actually managed to work out and figure out, and they've got code published for it as well. It actually works quite well. But I don't think anybody wants to scale Ethereum with BTC. So, yeah. Any other questions?
Thank you.
Nope. All right, then I think we can draw a line under it there. Thank you very much. I appreciate your time.